All right, geometry 8-1, geometric mean. So this is kind of like when you read mean, you think average pretty often. And we usually talk about the arithmetic mean where you add things and then you divide it by how many things you added. This is the geometric mean. This looks a little bit different. So we're going to write just a little bit here, and then we're going to show you how to do it. So we're going to write something. Actually, you're going to write it. I'm just going to show you it, and I'm going to talk about it, and then we'll do some examples here. So you can pause and write this down. I'm just going to talk about it. When the means of proportion are the same number, that number is called the geometric mean of the extremes. Okay, write this down. You might see it again later, or you might not. And once you've done that, we're going to draw what that means. Here's the extreme is a over x equals x over b. So the extreme here is this one, and the other extreme here is this one. And then here's the mean, and here's the mean of this one. So a over x equals x over b. If I were to cross multiply here, then I'd end up getting x squared equals ab. And then I take the square root of both of these, and I end up with x equals the square root of a times b. And this is the formula that we use for the geometric mean. This might mean nothing to you, and that's okay. Here's the most important thing that we're going to use when we are asked to find the geometric mean. So let's do some examples. Find the geometric mean. So find the geometric mean between 8 and 10. So let me make that 8 a little bit better. What we're doing here is we're saying this number is A, this number is B. We're trying to find the geometric mean between these two numbers. X equals the square root of A times B. That's our formula that we're going to use for the geometric mean. So using these numbers, we have x equals the square root of 8 times 10. And so now what we have to do is decide how we're going to simplify this. I don't want this to just be plugged into a calculator. I'd rather it be broken down, and the answer should be in terms of the radical. So we're just still going to have a radical left if this isn't an easy square root here. So what I'm going to do here is I'm going to just factor each of these. 8 is 2 times 2 times 2, and 10 is 2 times 5. So 2 times 2 is going to be, the square root of 2 times 2 is 2, and the square root of 2 times 2 is 2. So I get to take these out, and the 5 has to stay in. So x equals 2, and then I pull this other 2 out, 2 times the square root of 5. So that goes here, and 5 is left over. 2 times 2 is 4, and the square root of 5. So the geometric mean is 4 times the square root of 5. Let's do another one. Between 5 and 45. So all I'm doing is saying this is A, this is B, x equals the square root of 5 times 45. And then I'm going to factor this so that I can simplify here. So 5 times 1, I'm not going to write a 1 down there. And then 5 times 9, 9 is 3 times 3. So look, I get to take out a 5 and I get to take out a 3. So 5 times 3 is 15, x equals 15. Okay, you do too. 12 and 15, and you try 25 and 10. Okay, so do those two, and then we'll come back together and check out how you did. Go. All right, let's check it out. Okay, so this is A, this is B. X equals the square root of 12 times 15. And then I'm just going to factor these out here. This is 3 times 4, and this is 3 times 5, and this 4 is 2 times 2. So I've got the square root of 4 and the square root of 9 here, and then I've got that 5 left over. So the square root of 3 times 3 is 3. X equals 3 times 2 times 2. The square root of that is 2. And then the square root of 5 is left over. 3 times 2 is 6. Times the square root of 5 is my answer. Let's check this other one. X equals the square root of 25 times 10. 25 is 5 times 5, and 10 is 5 times 2. So I've got two 5's here, and this 5 and 2, I can't do anything with them. So x equals 5 times the square root of 5 times 2, which is 10. And that is how you find the geometric mean when you're given two numbers. Now we're going to look at the geometric mean having to do with triangles. So here's a theorem. Right triangle geometric mean. Okay, so let me show you something called an altitude. Altitude. If I have a right triangle that looks like this, remember right triangle means it has a 90-degree angle. And an altitude is a line segment that is drawn from a vertex to the opposite side at a 90-degree angle. So it's got to come from the vertex down to the opposite side at a 90-degree angle. That's an altitude. And so we're going to label this triangle a little bit because we're going to write about it. So this altitude here we're going to call h. And then this segment here between where h hits this side and the vertex here is x. And then from here to here is y. All right, h is the geometric mean. Of x and y. What? That's weird. Yep, it's true. Because look, x over h equals h over y. So we can set up this proportion here based on right triangle, or our understanding of right triangles, that this triangle here, these pieces are in proportion to this triangle here. And so we can say this little side over the longer side, that's not the hypotenuse, is in proportion to this little side over this longer side that's not the hypotenuse. And so that's the proportion that we set up right here. And so if I were to cross multiply, I would get, again, h squared equals x times y, and then I take the square root of both sides, and h equals the square root of x times y. Now, notice I'm not putting plus or minus the square root of x times y, and that's because this is a distance here. It's got to be positive. That's part of the reason, but anyway, okay, that's a good enough reason. All right, now let's see if we can we're going to write a little bit more, then we're going to do some examples. So here is the altitude. We have the altitude one here, and then now we have a leg one here. So let's draw another triangle the same way that we did just moments ago with a right angle here. We've got this side A, this side B, B, this side A, and this side here is going to be C. And then we have an altitude here, and this is X and this is Y. So there are some proportions that we can use based on this configuration here. So C over B, so C over B equals B over X. So B is the geometric mean. B equals the square root of C times X. Let's do another one. C over A equals A over Y. A is the geometric mean. Notice how A is in both of these. And A is the square root of C times Y. Okay, so let's look at these proportions here real quick. So C over B, so C is the the hypotenuse, and B is the short leg. And so this is, we can set up this ratio as a proportion, this short leg and the hypotenuse over B over X. So B is the hypotenuse, and X is the short leg. So I've got the hypotenuse, which is B, and the hypotenuse, which is C. So both of those are on the top, and they are over the short leg. So in each triangle. Now let's look at this one. So I've got C over A. So C is the hypotenuse still of the large triangle over A, and that's the longer leg. And now we're going to look at the smaller triangle here. And the smaller triangle has A, which is the hypotenuse of that smaller triangle, over Y, which is the long leg of that triangle. So really, for this leg one, we're putting the hypotenuse over either the smaller leg or the hypotenuse over the longer leg. All right, let's see if we can use this information to do some examples. Find X, Y, and Z. All right, I have a triangle. Looks like this. It is a right triangle. And there is an altitude here. I know it's an altitude because there's a 90-degree angle and it comes from this vertex here. And this is triangle JKL. And this distance from K to L is Z. This distance from L to this point here, which is M, this distance is X. And J to L is Y. And now M to J is 5, M to K is 20, and J to K is obviously 25. Okay, so we need to find out what X equals, what Y equals, and what Z equals. Now, let's go ahead and we're going to need to use these formulas here in order to figure these ones out. And so let's go ahead and find the altitude first, I think. Is that what I want to find first? I think so. I want to use this altitude, these notes that we just took, to find this. And so if I look at this altitude, the altitude equals the square root of X times Y. So the altitude equals the square root of these two pieces of the larger hypotenuse. Okay, so what I'm looking at here is this is the altitude, so that's x. X equals these two pieces multiplied by one another, and then I take the square root of that. So 20 times 5, the square root of 20 times 5. That's going to get me x. That's my altitude. Those two pieces multiplied together, take the square root of those, I get that altitude. So let's see, this is 4 times 5, and that's just 5. I'll just put that down there. And this is 2 times 2. So 2 times 2 and 5 times 5. So if I were to take those out of the square, if I was to take the square root of 2 times 2, then I get 2. So x equals 2 times the square root of 5 times 5, which is 5. So x equals 10. Okay, now that's going to be, that's my altitude there. Now I want to find y. Okay, so y is this one here, the small leg. So now I'm going to use this leg stuff that we just learned here. So my leg, my small leg, and my hypotenuse, and then I have my my hypotenuse and my small leg, and my hypotenuse. Okay, well maybe I have to do my long leg first. I think I should do my long leg first. Okay, so I'm going to actually set this proportion up first, so that I can, that might help me make sense of this. So my proportion here is my hypotenuse, remember, over my long leg. So my hypotenuse is 25 over my long leg, which is z, equals my hypotenuse z over my long leg 20. So I have this big triangle, hypotenuse over long leg, and then in my smaller triangle I have hypotenuse over my long leg in this triangle here. All right, so that's going to get me z squared times 25 times 20, and then I need to take the square root of both those sides. So I'm just going to set this up here. Now I can see it. 25 times 20. So the z equals the square root of 25 times 20. Now, 25 times 20, that's 5 times 5 times 5 times 4, which is 2 times 2. And then I have this 5 left over here. So square root of 5, square root of 25 is 5, square root of 4 is 2. So that means 5 times 2 is what I take out, which is 10, times the square root of 5 is left over. So z equals this, 10 times the square root of 5. All right, now let's do this last one. So I'm going to look at this big triangle here, and I'm going to look at this little triangle here. Is that what I'm going to do? Probably. Okay, so I'm going to have my hypotenuse, which is 25, and I want to find out what x is. So my hypotenuse over my, let's see, I'm going to do the short side, which is y. So my hypotenuse over y equals, so that's my hypotenuse over my short side, and then my hypotenuse over my short side of this triangle here. So that's z over x. Oh, wait a second. What am I doing? Am I doing something wrong here? Oh yes, I need to say my hypotenuse over z, my hypotenuse. Why am I doing this wrong? Z equals, y equals, oh, I already found x. What am I doing? I'm trying to find y. Yes, okay. Oh, goodness. 25 over y equals y over, so I've done my hypotenuse over the small side, and then my hypotenuse over the small side. So this is the small triangle, here's my hypotenuse, here's my small side. So y over 5. Sorry for the confusion. Okay, When I multiply this out, I have y squared equals 25 times 5, or 5 times 25. Take the square root of both of those, y equals the square root of 5 times 25. The square root of 25 is 5, and I have this 5 left over. So that means y equals the square root of 25, which is 5, and then that 5 is stuck there. Y is 5 times the square root of 5. Okay, so you can see, yes, this can be kind of confusing, but here, I'm going to have you do one on your own. Anyways, let's see if you can figure it out better than I did. All right, here we go. Here is a right triangle, and I have an altitude coming out here with, there's my 90-degree angle. This is x over here, this is y over here, this is z here, and this is 8, and this is 25. So I again want x, y, and z. Okay, use that information, use our example here, and see if you can get those without me, and then we'll be right back. And we'll check your work together. All right, go ahead and pause and go. All right, let's see how you did. Okay, so let's see here. I'm going to say that this is my short side, this is my long side. It's kind of hard to tell, but that's how I'm going to go about this. Now, z is the altitude, and remember, altitude is these two pieces multiplied by each other, and I take the square root of them. So that one's kind of the easiest one to fit in my brain. Z equals those two multiplied together underneath the radical sign. And so 8 is 2 times 2 times 2, and 25 is 5 times 5. I can take those 5s out, those 2s out, and I'm left with that 2 right there. So 2 times 5 is 10. The square root of 2 is left in there. Z equals 10 times the square root of 2. So that's Z. 10 times the square root of 2. Okay, now x is going to be, so let's look up here and see if we can figure this out a little bit. So here's the small side, which is b. b equals c, which is the hypotenuse, times x, which is this little bit here. So let's see if we can use this to help us. The hypotenuse and that small bit, or the bit that's adjacent to it, that's connected to it. All right, let's try that. So let's say I want what x equals. X equals the square root of the hypotenuse, which is 8 plus 25, so that's 33, times this little bit here, which is next to the x, so that's 8. Let's try this again real quick with the y. Y is the hypotenuse, square root of the hypotenuse, which is 33, times the bit that's next to it, 25. Okay, that's way easier to think about it, isn't it? Yep, I forgot about that nice little trick that I used to use. Okay, let's keep going. So let's break this up. 33 is 11 times 3, and 8 is 2 times 2 times 2. Ooh, there's very little I can take out here. I can just take that out, and the rest is stuck in there. So I've got 3 times 3 is 33 times 2, which is 66. And I can only just take out this 2. So x is 2 times the square root of 66. Y, let's try this one. This is 3 times 11, and this is 5 times 5. The 33 stays, the 5s go, square root of 25 is 5, so I end up with 5 times the square root of 33. And that is 8-1 geometric mean. All right, good luck on the homework.